Assalamu alaikum. Hello everyone. This seminar was delivered as part of the Tech Workshop series for UTAS. The workshop is about Geogebra, and all these three modules actually, they are for absolute beginners. So the Geogebra, the home of Geogebra is this website, their website geogebra.org. If we go to home here, we have all these apps. So it is actually a collection of apps, Geogebra is, and all these are listed here. You just click any of them here. It is calculator suite, which has built-in into it. Further, some apps are separately 3D calculator, CAS calculator, geometry. So these are separately available. Let's say if we click this one, calculator suite. So this is the calculator suite, and we have graphing in here. This one is for standard graphing, like for calculus or for any other subject. So these are our taskbars, icons, and all that tools. There is a spreadsheet available here, and this is our input bar where we can add functions. Today I'm not going to do the online version of the app, so you simply just add the function and it will plot and all that. I will explain more this in the Geogebra Classic version. Okay? We can change the sub app, like for example 3D calculator. So this one is specific for 3D graphs, and these taskbar icons, they change. Some of the 3D ones are added here now. And if we go to geometry, graphing and geometry, they have same similar taskbar and similar tools. CAS do not give any tools here, but it's more when we write a command, it will search live. For example, if you write solve, it will display the help, so you can easily choose from and you can select and what you want to do. That's not a problem here. We don't need to remember the commands for this part. Calculator suite, which has further 3 or 4 apps in it. Now the other way to use it, open a separate 3D calculator app. It's all the same. They work exactly the same. You can work in them even without signing in. You don't need to sign in to work with them, but to save your work, you must be signed in. The one which I'm going to use is called Classic 6, version 6. That one is this one. This is installed in the laptop. It's a desktop version, they call it. I have another video, small video, with how to install and how to create your login. Please watch that video if you have not yet, and you can install this Classic 6 version and you can create a login. Today I'm going to deliver the whole seminar on Classic 6. It would be a good idea to first learn the basics of the app with some fixed version, and then you can explore other versions. You can work with online. So this Classic 6, you can use it in 2 ways. One is this one, the installed version. You can also use Classic 6 online. Here it is, Geogebra Classic. If we click Geogebra Classic, and you see the interface is exactly the same. This is now the online version. It's running from the website, and it has exactly same interface as this installed version. As you see, no difference at all we feel when I am shifting from installed version to classic version. You can use the classic version online, this one, as it is exactly same, but once again you need to be signed in order to save your work. So from now onwards I'm going to explain everything with Classic 6. So let's go there. This one is Classic 6. Yes, one more thing, there is also Classic 5, version 5 available on website of Geogebra to download and install as a desktop version. I'll show you. This one is Classic 5. You see a slightly different interface, although the 2 taskbars and these tools are almost the same, but there is some other functionality differences between 5 and 6 as well, which I'm not going to get into right now. It's a little beyond the scope of this seminar. But those people who work with animations, which we will discuss in module 3 of this course, For animations, many people prefer GeoGebra 5 because of its some of the features which were later removed from GeoGebra 6. But today, as I have mentioned, I am only going to use GeoGebra Classic 6. It has built into it all the apps which I have just shown you: graphing, CAS, geometry, 3D, spreadsheet, probability. These two, this probability was not available online, but here we have probability as well. And we will go into little bit of introduction kind of details of all of them, and then we will try to discuss some of them in a little bit more detail. And before I get into individual apps, I will like to explain the interface. Let us start with menu bar. This one is called menu bar on the right side. It has file where we can open a new activity. We can open from our computer or from online. If we click, we see that this one is the online icon and this one is our computers folder. We can open from either online account or from our computer. Save. Let me just first make a graph so that we have an example to show. We have these two graphs shown on the screen, and if we would like to save them and we click the save button, now we see that it gives option of shared or private, because it is not saving them on my computer, rather it is saving my work into my online account. If I say, let's say test function 1, and then let me just keep it private for now. Private means it won't be visible to others in my online account, and I go to my online account, and here under the home there's resources and now mine. Okay, so these are my resources, the one I have created or copied into my account. Here it is, test function 1. If we open it, and these are the two graphs which we have just plotted. This is x square, here it is, x square and x cube. Save button in GeoGebra Classic 6 and GeoGebra Classic 5 as well. It saves your work online and not on your computer. Okay, you can open this saved work directly from online. Here it is, test function 1, and you see that it is coming in the this icon, GeoGebra online icon, and here it is. You can open it directly from your online account into your installed app, the desktop version of that. Or if you have saved something else on your computer, you can click the folder button and then you can open it from the computer. Let's go back and see how can we save the same onto our computer. For that we have to go into download as. So this one, download as. The first one is the most important one, GeoGebra file, GGB. If I save this one as a GGB file, save, and let me say if I save it in this new folder, I think I have saved one already during the live talk, maybe. I'll update it, and we save it, and let's say just replace it, that's fine. Now our file is there in the new folder. Here it is, and there it is. Okay, so we can open it from here and we can work with the file again. But if you download as any others, especially these ones in the middle, for example PNG, SVG, these are just the picture, the image of our work. So we will not be able to edit it if we save as an image or SVG or PDF. Next is edit. Well, this one has standard icons which we can use within this canvas, like undo, redo, copy and paste, and object properties, which we will discuss when we go to style bar, and select all and all these. Next one is perspective. In the perspective we can change the apps. Okay, for example, right now we are in graphing. We can go into CAS. If we click CAS, then our taskbar changes. Okay, you see now the taskbar icons are different. We still have an input bar here. This is the algebra part of the app, and we still have an input bar here, but the taskbar has changed. Now we have integral, derivative, solve, substitute, factorize, and all that. And if we go into geometry and graphing have same taskbar. Okay, so it's back to the original graphics taskbar because they have the same. This input bar has vanished. Yes, this is one thing which we should keep it on the arrow if you don't want to click here and there. To show the input bar, you can either go here and turn on the algebra, or you can click this one, which gives another input bar down here if you want the whole screen just for the graphs. So I will for now I'll just use this one. So from perspective, I was talking about perspective, 3D graphics, again it changes the appearance to 3D, and as you can see our graphs are plotted into 3D within the plane, of course, because they are only two variables. But our taskbar has changed somewhat, and we have some 3D options there now, which they were not available in graphics view. Okay, so you can see that rotate 3D and some cones and pyramids and all that. And then there is a spreadsheet, and probability spreadsheet is like an Excel sheet. We can do the work some of the work which we do in Excel we can do here, especially the sum and the graphs, the bar graphs and all that. And in probability, I'll come to probability in due time, and I'll explain what some simple examples in probability. And again, you can see that our taskbar and everything has changed. So I'll go back to the graphing perspective. So this one is the one which we are going to work with right now. There is another option, view, here. Again, we have kind of the same list of apps. So what is the difference between perspective and view? Perspective will change the taskbar. It will change the appearance of the screen, and but the view option, it won't change the appearance, not much. For example, let's say if I turn on CAS here, so it did change the taskbar, but let's see, this one, this column is added. This one is the CAS column here. Okay, you see this, it has a different sign, CAS column, X equals kind, and this one has a graph here. So this one is for the CAS, for computer algebra system, to do symbolic mathematical works. If I go back and click here and or click in this one, now you see the taskbar changed back to graphing. Okay? So and when I come here, it switches back to CAS. Now the view will put all those selected side by side. So now we have three of them selected: algebra in the first column, CAS in the second column, and graphics is in the third column. We have another graphics here, option for graphics 2 as well. Sometimes when we are preparing animations, which we will do in module 3, we might need two columns for graphics to place different things into one, and some graphs into two. 3D graphics, we can as well open 3D graphics even with that. So all four are open now. As you can see, algebra is open, CAS is open, graphics 3D, all four are open side by side. If you need to, you can of course do this as well. Okay. For now, I'll only keep algebra and graphics open. There is this construction protocol. Construction protocol is a very useful thing in GeoGebra. It records your steps. Okay. For example, in module 2, we will discuss how to change already prepared activities from the resource center. If I go back to resource center, and here is the resource center, and there are many millions of ready activities there. So if I would like to edit any of them and I open them in the app, then how do we added them. Sometimes it is very useful to look at their construction protocol. How were they prepared step by step? So for all these activities, the construction protocol is saved with the app. So we can have a look at the construction protocol, and we can easily learn how to do them, and this is good for learning, this is good for changing them and making new ones. But please do note that construction protocol has its own style of recording things. It won't be like a step-by-step guideline as to click this first and click that second, and not like that. You might need some practice to understand how the construction protocol works, and some know-how about the general framework of the apps and GeoGebra, and then you can make sense of construction protocol. But it is always very helpful. It has helped me quite a lot when I was learning GeoGebra. So, and that is one more reason why they have given an option for download as construction protocol separately. So what we can do is we can download the construction protocol separately as HTML. Let's say if you have two screens available and you open the construction protocol HTML file in another screen in a browser, and then you can look at that screen and copy the steps into this screen one by one, and that's very helpful. But remember that construction protocol will only be the steps. Okay, as I have said already, we better save the file as GGB, download as GGB if we want to open it again and edit it again. Right, that's about menu bar, which is right here. There is settings, which we will discuss in couple of minutes, and then there is tools, a customized toolbar. This is a very interesting option here. Create new tool. We can even add more icons here in the taskbar, and we can, for example, if you are going to work on something particular for quite some time, and you don't want to type commands every single time, you can type them here, add them into the toolbar, create a new toolbar, and just click and add into your work. Okay, I'll see if I can show you an example. Otherwise, I'll mention them in module 2 somewhere. Okay, right. This one here, small palette. This one is called style bar. This one, it changes according to whatever we are working on or whatever we have selected. For example, right now I'm clicking into the graph. Okay, so it is giving me properties of this Cartesian coordinate system, the one which is in front of me. For example, do I need the axes or I don't? Okay, so if I click, they vanish or they appear. This is the grid. For right now there is no grid. I can click on the grid and now we can see the grid. Okay, grid is on. Or for polar coordinates, we want a circular grid like this one. Also we can go into this one is home button. For example, if I have moved the graph for some purpose, and then I click on the home button, and it will bring the 0, 0 coordinates to the center, or whatever I have declared as center. So it will bring it back into center. This one is a very useful option here, snap to grid. This is called capturing, point capturing. Okay, it is given here again in the grid. Here it is, point capturing. Okay, these are the options which are given outside as a quick option in this magnet. Snap to grid, fix to grid, off. Right, so our function is xcare. So we can move the function around. Okay, if this lock is open, then we can move the function around, and accordingly the equation also changes, and you can see that it's 0.04, very slightly above the origin. Okay, very slight. And snap to grid. Okay, snap to grid. Now it will be much easier. Let's say we leave it here, 2 and 1. Now we leave it here at 1 and we leave it here, and that's very easy to move it around and leave it at the integer points. Snap to grid. Also note that while we have selected the graph, it's highlighted, our style bar has changed. It is giving us options for the function now, not for the system. Quick color change, okay, that can be very handy. Quick line style change, we can change it to dotted dashed, okay, or show its captions or name or whatever, okay. Lock it, whether it can move or it cannot move. If we want the more details about the graph, okay, highlight, keep it highlighted, and then select the settings. This will give us settings for the graph. For example, color, more options here, style, line thickness, okay, line opacity, so we can change, okay, let's keep it here, line style, hidden line style. Advanced, we have condition to show. We will discuss this in later modules, maybe third. Then dynamic colors, we can put conditions under which the color will change. So same graph can have more than one colors if we put conditions here accordingly. Scripting, this GeoGebra is written in JavaScript, okay, and as you can see down here, you can, if you know Java, you can do things which are not available in the settings or in the taskbar or menu bars by using Java programming script, okay, right here. Generally for beginners it is not needed. You won't need it for simple and starting works. All right, so now let's see some more options for our system. There are some basic options. For example, right now we can see x minimum is minus 12 point something, x maximum is 3 point something, you see it's near 4 almost. Y minimum, y maximum, we can change them if we want to. Ratio 1 and 1, this box size is 1 to 1, but we can change it. Then show axes or don't show axes, show them bold, now they are bold, and their color, line style and all that. So you can just play with them. And background color, for example, if you want to change background color of the whole canvas, so that's background color changed, but I'll keep it white for now, okay. Right, so for x-axis we can show axis, show numbers, so the numbers are gone for x-axis, okay. This is only for x-axis. Only positive direction, so the negative is gone now. Distance, how would you like to measure the distance? If you want it to be with gap of 2, so now it is with gap of 2, okay. But I'll keep it default, gap of 1. Label, if you want a different label for x-axis. Unit is very important. If we are working with trigonometry, we would like pi or something like multiple of pi to be, and you can put the distance accordingly. For example, when you have pi by 2, or even you can change it, say pi by 4, okay. So now it's pi by 4. And please note that in the unit there is no option for numbers. So how do I go back to numbers? Okay, so what I will do is I'll just first disable this and simply just delete it, and it will go back to numbers. Okay. Similar, very similar is the options for y-axis, and then there are some options for grid. This one we have talked about already, snap to grid. Major and minor grid lines. We can see that there is a very small mesh between the major grid lines. Sometimes we don't want that, so we can just turn on the major grid lines, and we see that that small mesh is gone now. Okay, so we have discussed menu bar and the style bar and a little bit about the taskbar. I'll come to taskbar later to discuss a little bit more details. For now, we have already discussed the function settings. When we click on the function, this highlights and we can go into settings of the function of this graph particularly. or you can right click on the graph and you can go into settings of the graph. That's the same thing. There is one more gear icon here. This is for if you are doing any decimal work here in the algebra view and you are doing some calculations which answer you in decimal, you can fix the decimal place here in this option, or significant figures if you would like, and labeling, and then font size and all that. So this is another set of settings which affect the whole work as collective. This caption or label, so if we select here and show label, this one has many options there. Name is the name of the function which either we give or GeoGebra gives automatically. Name and value, it will display the full value of the function, like this one as displayed on the screen. Only the value, for example, its value, now the definition of it. Caption, we have not given any caption here. For example, you do not like the name, it is too small, and you would like to write f of x as a caption, and you want to show the caption. So that's now only the caption is shown, and we have put here in the caption this thing. You can write anything here and then display that, okay, for this function. And caption and value, show the caption and the value of the function. So you can also click these three dots to go into settings of the same function. So there are 2-3 ways to go there. Or we can delete or duplicate input, just in case if we want to enter a similar function. So we duplicate input and change, let's say this to 5, and enter again. So we have new function g of x, which now let's see what we can do here in the algebra view in this column. Let me delete these two functions and start again with a fresh canvas, and let me start again with also let's see if I enter only x square. Now to enter x square, you can click here, and there's a keyboard, built-in keyboard, which is usually minimized. So you can see down here, this one is the keyboard, and it's full-fledged latex style keyboard. We can click and add almost any command. One way to write x square would be simply use the keyboard, x from here and square from here, and it will write x square, or any powers, square roots, any less than, greater than, mod. And here we have trigonometrics, log, e, and all these brackets as well, derivative, integral signs, then full alphabets and Greek letters. Then we have Boolean operators and other symbols here. So we can click and add using this keyboard right into the input bar. That's one way to do it. GeoGebra also supports LaTeX. So for example, if I am writing from the keyboard and I write X wedge, we don't see wedge, but when I will, it goes up, the cursor goes up, and then square, bring it down, otherwise it will start writing there in the power. So bring it down, enter, and it will give the function a name and it will type the function. This one I find it easier rather than clicking on the keyboard, but sometimes of course we might need this keyboard for inserting symbols or something. So this is our function now, f of x equals x square. Again, let me as a habit, I usually name the functions myself. So g of x is x cubed. Now there are two functions. Let's say I do not want to see the graph of g of x. Simply click on this color dot for g of x and it will disappear from the graph. Okay, but it is still there if we want to make it appear again. So we can just click on this color dot and it will appear or disappear. Next is how do we do operations using our function. For example, let's say if I give f of x plus 2, okay, and it will make it a new function, h of x, which is x plus 2 square. We can write x, we can write f of x plus 2 outside, or let's do minus 2. So that is p of x is f of x minus 2. So we can use f as input and do operations on f. For example, let's say root, okay, root of the polynomial, and our polynomial is f, and root is 0, 0. So you can do lots of operations directly by using f as input, and you will get an output. Rotate, for example, you can directly rotate object and angle. Now our object is f, as it was corrected during the live lecture. Angle, the default measure of angle is radians, so we better put it in pi or pi by 2 multiples of pi. And we have, let's disable the others so that we can see what we have done in the last one, root as well. Yeah, so this one is now f, and it's rotate f1. They are drawn on the screen. We can change color. Let's change it by right clicking, settings, color, and let's do blue maybe. Okay, and now it's blue. Right, let's see what else can we do. Well, we can do anything which is possible with this function. For example, there is a command called intersect object and another object. So let's intersect f with x-axis, function f with x-axis, and a lot more we can do. For example, let's say if we want to see, well, for this function it won't be very visible. Let me choose once again x cube for that operation, and let me highlight x cube, and also okay, so that is our x cube, g of x, and I give a command g greater than 0. When I say g greater than 0, then it highlights only the domain of g where g is greater than 0, it's positive. And if we give g less than 0, it will clearly, yeah, but the problem here is that we have same color. We will have to change the color of one of them at least. Let's change color this one to green. So there it is. So our g of x greater than 0 is blue, and g of x less than 0 is green. Let's make the curve color to be, oops, sorry, that's the wrong one. I wanted to change this one, settings, color, red. Yeah, so now a little better. Right, so we can, as you see, these commands I am giving, it is not listing them in the order of construction. The last command I gave was g of x less than 0, but it has come up here in this group. It is grouping them by their properties like inequality, parametric curve, function, point. But what if I want them to appear in the order of construction, the way I am giving the commands? Click this button, this icon here, and these two dots, and change it to construction order. Now you see the last command was g of x less than 0, so that is the last one. If you want again to make it object type, the way it was by default, so you can change it to object type or construction order. For now I'll keep it as construction order. Right, I would strongly recommend that all of you please open the app. If you have installed it, then Geogebra Classic 6 would be good. Otherwise, go to Geogebra home, geogebra.org, into home, and open Geogebra Classic. Okay, Classic, because the Classic has exactly the same appearance as the one I am working with, so there won't be any confusions where the icons are, and they have exact same location. And please think about a question in your mind and then try to answer it. For example, set a target, you want to do something, and then how would you achieve it? Okay. For example, one question right here that is coming to my mind is, I have highlighted g of x greater than 0 where g of x is positive and g of x less than 0 where it is negative. Can I do the same for the derivative? Do I need to first calculate the derivative and then do that, or will it work directly? Well, try it and see how does that work. So let's try some other commands. So our first inequality is x minus y less than or equal to 3. How do we put the less than or equal to, greater than or equal to from the keyboard? Simply write greater than sign from the keyboard and then hit equals right after it, and it will convert into greater than or equals 2. That's our second inequality. And our third one is less than or equal to 4. And there it is. Our solution area is highlighted already. Let's, for example, if we have an integral. Now you see that we do not need to remember the commands. The moment we start typing, it can complete and give ideas on what are possible commands with this one, and they are very intuitive. Integral is a very common command, and that's the word with which you would search for it. And integral of, let's say, x square. So that is integral of x square. It's a symbolic integral. We did not give any limits. Okay, but what if we have, as you can see here, start value and value. So let's say if we do x power 4, start value is 0 and value is 1, and that is our, let's say if we have a parameter attached to our function, a constant which is not defined in our, so we ask the integral. Oh, I see. Okay, what has gone wrong here? Actually, the problem is a of xy, because I think we have a defined here, and a is an inequality which is dependent on x and y. That's why GeoGebra automatically changed my a value into a of xy. So let's try it again with some different variable. So let's try integral m. Maybe we have not defined m here. X square, yeah, with respect to x. Yeah, that's better. So let's disable this one. Now you see that GeoGebra did answer mx square, but it has posed a value for m by itself and has given a bar as well. If we slide the bar, it will change the value of m, and accordingly it will change the answer of the integral. Okay, and you see now when m goes to 0, our answer goes to 0. So it means algebra view of the GeoGebra cannot do this symbolic integration where m is unknown. It has to suppose some value for m. We can, although we can do this one in CAS view, okay, which we will do in a few minutes. Okay, and then I'll mention it again. So this is one thing to remember. We can of course do the definite integrals, any kind, because that will have a numerical value, like this one. Let's see if we do x square, and I just want to show something. That is 0.33. Yeah, that's what I wanted to show. So the answer is 0.33 up to 2 decimal places. What if I want to increase the decimal places? Where was the option for increasing decimal places? Think about it. To find settings according to the problem, it was right here in this one, this gear icon, 2 decimal places. Let me change it to 10 decimal places, and there we go. It changed to 10 decimal places. Okay, but for now I will keep it to 2 decimal places. Okay, yeah, and there it is. Right, next, now we are going to go into our keyboard again, but not this part of the keyboard. There are these 3 dots, and what are they hiding? These 3 dots are hiding a lot. Right, these 3 dots, if we click, they have a very huge list of commands which we can give here. Some are CAS specific, which will only work for the CAS view, but some of them will work in algebra, graphics, 3D and all that. For example, let's just explore some of them. I would strongly recommend to just try some of them which are in your area of expertise, in your subject of teaching. Okay, and see how they work. For example, I can see here denominator number, and then it says denominator function. Okay, denominator number is very clear. Let's try it. So denominator number, what would this do? It should give me the denominator of some number, 1 over 3, and 3 is the denominator clearly. Generally, I prefer to type rather than clicking and adding, because in typing, I have one thing, you see, this within the bracket, it highlights, and we can delete it like that. So now I want a fraction of functions. Just hit bar, this forward slash, the one which we use for divide on the keyboard, and it will make a fraction. Okay, there it is. I have hit the forward slash on the keyboard and it makes fraction, x minus 1 over x plus 2, and denominator is x plus 2. So like that. Okay, what else do we have here? Implicit derivative. Okay, let's try implicit derivative. Implicit curve, implicit derivative. Okay, this one. We would like x square plus y times cosine of, oops, that's wrong, cosine of x multiply y. And there it is, our explicit derivative of x square plus y times cosine of x into y. So similarly, so now sky is the limit. You can try anything inflection point. Of course, that will work on a curve. And integral, we have already tried it. Integral between. Okay, let's see this one, integral between. Let's say if I do not understand how would this command work, how exactly does this one work, I need examples for it. This is the feature of GeoGebra which I like the most. If you hit show online help, while this one open, integral between is highlighted open, and we hit show online help, it will go to exactly this function, integral between. That is very good. So you need help with some command, open the command, limit below, hit show online help. It will take you exactly to that page of the help. So now we can see integral between. There are examples, sine x, cosine x, 0 to pi. So that's very simple. We have to give two functions and then 2 points as a limit, and it will give us answer. Let's try some. As I said, I prefer to type here. So first I will give two functions. Let me hide these two and this one. Let's say our first function is s. Did we use s before in this? No, we have not. So hopefully we'll be fine. X square, and then our t is minus x square plus 4. Okay, I think we have zoomed in too much. Let's zoom out a little. So that's our graphs. Now we need to integrate between the points of intersection. Okay, so first we need 2 points of intersection. Fine, intersect s and t, and there it is. A and b are our points of intersection. Now if we remember from the online help we saw, where is the online help? Here it is, online help. It needs numeric values, not the coordinate ordered pairs. Okay, it won't accept a and b. If you remember, even during the live lecture, I was stuck at this point because it was not come into my mind quickly that I need x coordinate of the point only and not the whole point. So we give integral between, and integral between our top function. Yes, that is important that you write the top function first so that you get a positive answer for the integral. Otherwise it will give a negative answer. It will work anyway. So t is our top function, s is the bottom function. Our start value is x coordinate of a. Okay, so we'll write x of a. Okay, or you can separate them and then x of b. That will give it x coordinate of b. Now you see the only area between is highlighted, and we enter, and there it is, 7.54 is the area. If we don't want these A and B to show, we can right click and show label, and right click and show label, and they are gone. And if you want this to change to, let's say I want it to say area, I'll give the caption area, and here I will choose caption and value, and there it is, area is it's okay. So let's try a couple more. I don't see these three dots here anymore, so we can do is cross and it goes minimized. Let's quickly try a couple more. Okay, we can find commands by the categories, most of the time. For example, functions and calculus will have related categories like implicit derivative and all that, integral, between, and similarly conics, they have conics related commands, and so on. Vectors and matrices, they have identity, dimension, rank, reduced row echelon form. I'll discuss reduced row echelon form when I go to CAS, and so on. All these, probability, let's see, it would have all the distributions there, and scripting. The scripting is the commands of Java which we can take help of. If we know what they do, we can check help. And for example, sometimes this one is very useful, set condition to show object. You can see how it works, and then when we make animations, then we can use something like this. All right, let's try some of them. For example, if I use solve, and there is an equation, and my equation is x square minus 4 equals 0, and I have the answers x minus 2, x plus 2. What if my equation is x square plus 4 equals 0? What would the answer be? This has complex roots and I didn't get any answers. Now let's try complex, and there it is, complex root, polynomial, and we give x square plus 4. Again, we need to bring this back down. X square plus 4 equals 0. Okay, polynomial, we need to give polynomial, not equation, and there it is. Okay, complex roots of a polynomial, they are 0 plus 2 iota, 0 minus 2 iota, and it is even plotted them on the graph. Yeah, sequence, end value, sequence start value, sequence start value, end value increment, expression. This one is very interesting one and very useful one. Sequence expression. So let's say if I have k square and my variable is k and 0, let's say 1 to 3, and there's a sequence for k square 1 to 3. Similarly, exactly similarly, you can write sum, k square, and your variable is k, and sum is 1 to 3, and that is 14. Okay. Right, one last thing for algebra, it's piecewise defined functions. We really need them quite a lot in our calculus courses and related courses. So before we write piecewise, let's first start with the restricted domain. So let's say f of x is only defined from -2 to 2, and there it is. So our f is defined from -2 to 2. That part you can do straight away, just with a comma, give the range, and it will draw the graph in the with the restriction you add. If we want two definitions like piecewise defined functions, we will start with if. Okay, if, and let's say -1 less than or equal to x less than 0, and our first definition is x plus 1, and our second definition is x square. Okay, well, we don't need to give the range for the second one if it is in the otherwise sense. Okay, so now between -1 and 0 it is x plus 1, and otherwise of course applies to below -1 and above 0 as well, and otherwise it is x square. But what if we want it to be, let me change it to, if for x less than 0 we have x plus 1 and otherwise x square. Now we have something like this for x less than 0 and for x greater than 0. If we have more than two definitions, we can continue writing them in the same sequence. Let's say for x less than 0 we have x square, and then between 0 and 1 we have x plus 1, 2, okay, that's fine. And between 1 and 2, 1 and 2 we have again x square, let's say, and let's see how does that look. Yeah, there it is. Between less than 0 it is x square, then 0 to 1 it is x plus 2, 1 to 2 it is x square. I did not use otherwise. If I give the last definition, let me show you again. If I ignore the last definition, so let's click inside and see. So if we do not give the last definition, just like this one, we only gave one part of it. Less than 0 we have defined, and otherwise is x square, so it shows otherwise. But here we have given the complete definition, the last one, so it will write it like this, not otherwise, okay, because it has stopped at 2. So that is how we write piecewise defined functions. Can we add those hollow circles here? Sometimes in limits and continuity problems we have a function which is not defined at, so the 0 is defined to be 0 and not at 2. So this one is a filled circle and this one is a hollow circle. How can we achieve that? Think about it. That can be a good task to achieve and practice. One more thing, one more thing. Let me write a new function for that. Let me write gg maybe, because I'm not sure if g is available. Yes, g we have used already. X cube minus, not minus there, minus 3x square plus 4x minus 1. That's a very simple looking function. So let me change this to 5 so that we might get a little bit more curves. Yeah, this is better. Right, and we have this graph, and we right click here, we click here and special points. Now it highlights all the special points automatically. What are those special points? Look at them. They are extremum, okay, the two, this one, the maximum and the minimum, the roots ABC, okay, root of GG, there are 3 roots, and this one is the y-axis, y-intercept, okay, F, okay, F is the intersect with GG and y-axis. So these are special points of the function which are highlighted by just one command by looking here, and we have already done that, so that's why it's not highlighting anymore, because we have already added those special points. Okay, so that is one very quick analysis, simple analysis of the function. Right, so once again, these 3 dots are your friends, and this show online help is your bigger friend. Okay, CAS, computer algebra system. Let me quickly mention 1 or 2 things about this taskbar. Although most of the things in this taskbar are relating geometry, but some of them we can use with our graphs. For example, we can use a point. Okay, I click on a point and place the point here, so there is a point. Point is on GG, 2.76 minus 3.98. Now I can change properties of this point, and individually we can change color of this point. Okay, for example, we can select white, and I think I have answered one of the questions I asked a couple of minutes before, and we can change the color to red, and there it is, just that point is red. And also this point can move unless you make it fixed by selecting the point and hitting the lock, either by hitting the lock or by doing the fix object. Now this point cannot move because we have fixed the object or we select and lock. Okay, so it won't move now. Second option, let's say if you want to create a point or highlight a point at exactly 2.01 with x equals 2.01. So there is x equals 2.01 and our y coordinate is gg of 2.01, and there it is. Okay, so we can highlight a point at exactly 2.01 like that. These lines you can draw the line between. For example, if you select this one and then you select this point and this point, just like you draw a secant for the curve, or for example any other two lines. So this one, so we will you see, because I've highlighted the line segment, so wherever I click it will start putting lines. So better I disable it, go out of it by selecting this arrow and move. Okay, so now when I click anywhere. Okay, let's now go into CAS perspective quickly, and now I'm going to create a new one. No need to save this one, and I will view CAS. Okay, so this is our CAS. CAS can do symbolic calculations. Right, so let's start with the symbolic integral first of all, which we have seen when we do the symbolic integration here. Integral, let's say ax square with respect to x. Graphing view will create a slider for a, because graphics view does not understand what is a. It has to be a constant for graphics view to solve the integral, and our answer does not have any a. A is 1, and you can see that the answer changes, and we have seen this before. Right, let's try a similar problem in CAS view. So let's change the variable so that it is not mixed between the two of them, mx square. And now we have an m in the answer, clearly 1 over 3 mx cube plus c1 is the integration constant. It did create a slider for c1, but in graphics view, not in CAS view. Now, second thing which we need to note is how do we use any, as I said here in graphics view, for example, if I write f equals x square, and I can use, oh, I have used f somewhere, yeah, the f is used already, so that's why let me use g, maybe g equals x square. So now I can use root g and it would understand what g is. Whereas in CAS view, there are two ways to copy whatever is done already. The first one is, let me say I'm going to add a matrix here, m equals 1, 2, and this is a very easy way to enter the matrix, all the same brackets. M is the matrix, and I have used, so note that I did not use equals, it is colon equals. Okay? So that is how we assign variables in CAS. If I want to use m again, for example, I want to calculate eigenvalues of m, and I can, but m should be defined as it is done in languages, programming languages, some of them. So eigenvectors, or let's do reduced row echelon form of m, and there it is. Okay, and eigenvectors of m, and there it is. Now CAS has put both eigenvectors in one matrix. If we want to separate them out, You can separate them using element, okay, if you want, for example. But now you see there's a problem. I did not give it any name. Let me delete this one. I'll go here and I'll give it a name. For example, I give it M2, and now we know this row of cas as M2, and if I give it another M2E, let's say an element of M2, so we use element command, and now we have M2, and we want, let's say, 1 element, and there it is. So 1 element of M2 we have extracted separately. Similarly, we can also extract the whole row using the element command, okay, and then we can plot them if we want as a vector, and so on and so forth. But some of the things, as you can see on the side, M has gone into automatically. This M is appearing here, okay, but eigenvectors and eigenvalues command is not directly available in graphics view. For example, if I give the same command here, although as you can see, eigenvectors command is copied into graphics view from here, okay, although these two did not copy because I did not give them a name, as you can see. But this one I gave a name, it did copy in here. But let's say if I directly try to calculate eigenvectors here, okay, eigenvectors of M, and it tells me that command eigenvectors is available only in the cas view. I cannot use the command in graphics view. I can only use it in cas view, although using there with assigned variable will copy it on this side, and I can use M2 from here onwards. So let's say just like I did M2E, I'll give M3E this time maybe, or M2, yeah, okay, M3E is an element of M2. Which element? Let's extract this on 1, 2, and this is 1, 2 element is minus 8.74, and there it is. And again, we can now make a vector out of this M2. We can extract this second column by using this element command, and then if we want we can plot it as well in the graphics view. But again, please remember, not everything works exactly the same in cas and graphics view, okay? Not exactly. Some commands, they behave slightly differently. Same command behaves slightly differently in cas and slightly differently in graphics. Well, we have seen one already. We have used M again, and you see our integral has a value now, M, and it has multiplied our function with the same matrix. Very interesting. So because we unknowingly use the same variable which we have used in the determinant. Integration command, you see here, it can do an interesting symbolic integral where M is even a matrix. But the same thing, integral command here, it would never do the same. Although you see here it is M here, and even if I give integral with mx square, it won't solve because graphics view cannot do symbolic calculations. Right, so I was talking about plotting eigenvectors. So let's calculate them again. I'll call them eigenvectors of M, eigenvectors, and our eigenvectors are here. And now we extract our eigenvectors. Let's say our first element is element of EVM, and we want the first 1 element, and then in EVM2 we would like element of EVM, and we would like 2, 1, and that's it. Now we can make a vector 1, let's say, and vector 1 is start point is evm1 and the end point is, we have to give the command vector and our start point is evm1 and end point is evm2. There is an r extra. Let's delete the r, and there it is. All right, so please explore in your field and you'll find lots of ways to do things, ways around and all that. Let's try a couple more commands quickly. Solve command is a very important command, so I'll go to the all commands so that we can find it a little quicker. Solve command should be somewhere here. Solve. Yeah, here it is. Solve, and it says it can take list of equations and list of variables, but we don't know how to add list of equations. Once again, as I said, help is your friend, so please go to help and find out how do we. Here it is. They have given list of equations, just putting them in the bracket with the comma and the variables. So we will do the same, and we will add list of equations and then list of variables and see how it works. Yeah, as I said, something is wrong with my GeoGebra or my Windows. List of equations, we need to delete this help text. X minus y equals 4, and our second equation is x plus y equals 6, let's say, and our variables again in a command, again in a bracket, x comma y. Couple more, let's say limit above, limit below, very easy, 1 over x, and we give 0, and limit above should be plus infinity, limit below for the same should be minus infinity, limit below is minus infinity. So we can do any symbolic calculations in CAS view. Okay, I did not assign any values to any of them, so they do not go into graphics. For example, let me assign a value a here, and then it will go into the graphics view. But remember that limit above and limit below, they are itself not available in the graphics view. Okay, but I can use the numbers assigned a and b somewhere in graphics view. Right. One more very interesting usage of CAS, which I tell my students to do, is to learn algebra. Sometimes students struggle with very basic commands of algebra when they are started learning. So let's say if e power a plus b, and students want to check whether double equals. Okay, this one I achieved with double equals, or you can go into keyboard and equal with a question mark. So this one will check whether the expression entered by you is correct or not. Okay, let's try again. E power a, oh come on, e power a plus e power b, and that's false. Okay, e power a plus b equals e power a plus e power b, and that is a very good for beginner learners, our students, when they are learning algebra the first time. So they can check their calculations. So let's say many students confuse between a plus b over c plus d, whether it is equal to a over b plus c over d, and that's it, false. So this one is very useful command in GeoGebra, which can help students find out whether two expressions are equal or they are not equal. One more thing I would like to highlight, as I said earlier, that same command might behave differently between CAS and graphics view. All right, let me start with y equals x square. and now we can see the equation y equals x square. Another way to use previous function or previous command in CAS is to let's say if I say root, okay, root of $1. $1 means first row. As you can see, the number of rows they appear here in CAS view. Every row has a number. So root $1 would mean that I would like roots of this equation in row 1, and it tells me that it is x equals minus y square root and x equals plus y square root. It has taken the whole thing symbolically. So now let's enter the same equation slightly differently. Let's say f1, and we assign the equation, whole equation as it is to so our expression y equals x square is assigned to f1 now. Okay, and now we see the first difference is it plots the graph, and then it also copies it into the graphics view. But when we take root of, let's say, f1, and we will see the same. Yeah, so still our roots are being solved as symbolically, and we have calculated the value of x in the form of y. But for the same expression, it is written exactly the same here and here. Y equals x square is the equation and is assigned to a variable f1. So f1 is our algebraic expression. So we take roots of f1 there and we get 0, 0. Whereas here we get x equals minus y square root and x equals y square root. So that is one difference between the two. Okay. Which we need to keep in mind. All right, this one is my favorite. So we start with an integral. Let me call that integral f of n, okay, because I'm going to define it in the form of n, integral n x square between 0 and 1, and that is our f of n. Now I would like to take a sum over this integral, sum. So let me call this a new number. A is sum over f, where my variable is n, and I want n to range from 1 to 2, and 1 by 3 plus 2 by 3, that makes 1. So our this thing we can use like in Fourier series. We integrate and then take a sum outside. Okay, you can also make a sequence out of it. For example, we can make, let's name it b, and b is a sequence of values f with n going from 1 to, let's say, 4, and there it is. So it has ranged n from 1 to 4 and created a sequence. Okay, so this trick we can use. This set of commands could be used when we are studying Fourier series or something like that. It would be a very good idea to look at the online resources first and then work with 3D graphics more, especially from the point of view of calculus we teach, like area of revolution, surface of revolution, in where we need the 3D support more. I would really recommend to go through the online resource center online activities first. But let's quickly, as we can easily see that our 3D would of course plot functions with two variables. So let's say x square plus y square, and we can rotate and we can see different angles of the graph. Okay, so that is one very good thing which can be very helpful. Second thing, let's hide this one. Let's say if we simply plot this curve which is in the plane, in this plane, and we want to rotate this curve along some axis. So let's create 2 points, or let's just rotate it first. Or surface, our surface is f, and our angle is pi maybe, and there it is. So we have rotated, let's see, yeah, so our surface is rotated through pi degrees. What if we want to rotate it about some other line? We can create a point. Let me create a point in third and fourth quadrant of this plane. That would be -2, -2, 0. Yeah, that's the one. And B would be 2, -2, 0, 2, -2, and 0. Yeah, that's right. And now let's draw a segment. Let's call it B or C maybe. C is a segment or line, better. C is a line through the points A and B. So we have a line, and now we create the surface again, but this time we are going to rotate by pi through the line. Let's do it 360 degrees, 2 pi. That would look maybe nicer. Oops. Yeah, so there it is. We have rotated the parabola around the line which we created through those 2 points. Right. So I would strongly advise that please go through the online resources. We will discuss online resources in module 2 in very detail. What are the kinds of activities available there, and how to use them, how to copy them, and all that, and how to edit them. And please join in the module 2 for that, and we will go in more details. Generally, we do not need this this kind of 3D geometry. We don't teach it in undergrad level, but if somebody needs help with this, please do ask, and we can discuss. Let's quickly see our probability perspective here. Probability. Yeah, this is very useful. First of all, you can change the distribution here. Okay, so normal, student, chi-square, F distribution, and all that, they are given here. You can change the values of mean and standard deviation, and the graph will change automatically. You can change the probabilities, for example, within the interval, less than, greater than, and our graph will change accordingly. You can also calculate them from the graph by moving the graph like this. Okay. Similarly, in statistics, we have all these tests, z-test, t-test, and all of them, and estimates. The best part is we can copy this into graphics view, and let's see what it has copied for us. And here it is. It also tells us the detail of the function and the integral and the value, and this is much more information which we might need in some cases. This one, if you would like, you can, well, we will discuss this part in later in our third module. How do we create animations and all that, but if we do large, and there's our function, and that looks very nice, and it can be more helpful for students to learn. All right, and then quickly I'll mention 2 more things. This sliders and ABC text. Well, text is kind of intuitive. Just select the text, click in the graph, and you can add anything. Just write anything. For example, this is graph of, and that's it. And that's your static text. This is graph of, and if you want to add some LaTeX into it, okay, so come back, highlight the LaTeX formula. I'll do it again from here, and then I'll show you how to change properties. Highlight the LaTeX formula. It doesn't highlight really very clearly. It simply puts a very small box on it. You see, not big difference whether it's highlighted or not highlighted. But once it's highlighted, now you can put LaTeX in here. For example, dy by dx. It will be written in a very nice LaTeX form, dy by dx, and there it is. It has italicized it. And also one more thing that needs to be done a little bit more carefully. Let me change this now. Our text is here, LaTeX is highlighted, and this is our text. Let's say if I say in the same line that this is derivative of, okay, of g of x equals, what happens then? You see in the preview, because we have activated LaTeX, it will make it like an equation, no gaps and all that. So we have to add a command text, and then we have to enclose this whole thing into text, and now it is much better. Okay, so we have to enclose the text into the text command if we are writing LaTeX. The rest of the standard, the size, the bold, italic, okay, so this font and all that. If you would like to add any symbols, you can add symbols from here. It will give you preview here. This part I will discuss at the end in module 3. How do we make our text dynamic? If we add a function here, it will change as the function will change in our algebra view or graphics view. So that's about static text. One last thing I would talk about is sliders quickly. Let me start yet a new screen. Okay, sliders are very easy to understand. So let's say we insert a slider. We just select slider and click here. We can add a number with minimum, maximum, increment, or an angle with angle variations of 1 or any other integer. Okay, so it's a slider with random movements, or its shape is horizontal or vertical. It will show vertical or it will show horizontal, and then it is oscillating, increasing, decreasing. So all these options are there, but for now just let's go with simple slider -5 to 5 and increment is 1. Okay, and it will show it up here and it has gone there. A is our slider's name. What if I define a function y equals, or f equals, sine of ax? Okay, now a is changing through this slider. The moment a changes, our graph changes. Okay, now we have 3 sine x plus 1. Change this to, so we can only see change in one parameter. Okay, what if the c changes? So what happens to the graph? Okay, so if c is 0 and let's say a is 1, b is 1, so this is our original graph, just the sine x, and then so on, and then you can use these sliders very easily to explain many things in trigonometry, in calculus, and all that.